Now, let's start with our lesson here, which is the parent function. Now, the parent function, as you can see, we just summarized all of this function in the part one video. So this is the constant function, or it's look like, or a zero function, and this is the identity. Also, we call it as a linear function. This one is the quadratic function. It's like a U letter. This is the cubic function. Okay, and also we have the square root function, and we have the reciprocal function, or we call it rational function. Okay, and we have also here the absolute value function, and we have the last one is the step function. Okay, now if maybe I did not explain the step function in the first part, but let me just give you a small brief about it. So the step function, it's always like this one here. Okay, this one is, let's make it more bigger. Okay, so this one is the step function. Okay, f of x is a step function. What is the step function means? We call it also greatest integer function. Now, always when you have a number line, okay, and let's say you have when you have a number line, and we have here, this is 0, this is -1, -2, and 1 and 2. Okay, so let's say I have x. Let me give you a value for x. So let's say x is equal -1. Okay, so now you replace x with -1. Okay, you replace x with -1, and you put the point. Okay, now the second point will be, okay, that let's say it takes 0. So as you can see, 0 put 0, so it will be 0. So now just go draw 0. Now connect between 1 and 0. You will see a small line, or one step between the -1 and 0. Okay, and now what you have to remember about the step function, it's always closed and one open, and go one step up. Okay, closed, one step to the right, open, step up, one step open. So this is the step function. It's always like a stair, like you are going up one by one. Okay, now let's go to the first example here and analyze what the function is talking about. Describe the following characteristic of the graph, okay, of the parent function. So the parent function here is what? It's square root. Okay, we need to state the domain, we need to state the range, the intercept, symmetry, continuity in behavior, intervals, where it's decreasing and increasing. So now let's do it together. First thing, when you have a question like this, sketch the graph. Sketch the absolute value. How the absolute value look like? You have to memorize all the graph that we did. Okay, sketch it. So the first sketch that you have to do is starting from 0, 0, all the functions starting from 0, 0, and it goes like this to the right. Okay, so this is now the domain. This is the graph. Just small sketching. Now, from this sketch, you need to identify the domain. Always the domain, we say that the domain from left to right. So start from left, go to the right. So left, where is the left point? It's 0. So start from 0 and go to the right, where? To positive infinity. So the domain is from 0 to positive infinity. 0 to positive infinity. Now, how about the range? The range also starts from down to up. So down goes up. So down also, it's 0, 0 goes up. It's also positive infinity. So from 0 to positive infinity. So the domain and the range are the same. Okay, let's check from our answer. Okay, so the domain and range are the same. Now, the intercept. Intercept means y-intercept, x-intercept. Where is the graph intercept with the y or x-axis? It's here. So the only intercept that we have, it's at 0, 0. Okay, so now let's look to the intercept. It's 0 and 0. Now, number 3, it's symmetry. Is this one symmetry over the x-axis? Is there any graph reflected here or here or here? No. So is there any symmetry over the x or respect to the y or respect to the origin? No. So that's mean no symmetry. So you can wear the graph has no symmetry. Now the next one, the end behavior. Okay, what is the end behavior? If you look here, the end behavior, we need to find the limit when x approach to positive infinity and when limit of x. So now limit f of x when x approach positive infinity, and here on the left side limit for f of x when x approach negative infinity. Now let's find the answer. So first thing, when x approach positive infinity, so this is x approach, so the graph goes where? Goes up. Up means what? Positive infinity. Now, when x approach negative infinity here, is there any function up or down? No, I don't have any function up or down. So that's mean this term here, I don't have anything. So you don't write 0, you don't write I don't know, you don't write anything. You just write, okay, there is no, okay, limit in behavior for the function on the left side. Okay, so this is the end behavior. Then, what's next? The continuity. Okay, you remember the type of discontinuity. We have 3 types of discontinuity: removable, jump discontinuity, and infinite discontinuity. Do I have one of these? No, I don't have none of these. So the function is continuous from the beginning to the end. So the graph is continuous for all value in its domain. Okay. Now, the last one is increasing, decreasing. So the increasing, decreasing, always you start from left to right. And when you start from left, if it's going down, so this is term is decreasing. And when you start down, it goes up. This one is increasing. So now the graph from left to right, it's left from here. And it was what is increasing. Do I have decreasing? No, I don't have decreasing. Let's check from the answer now. So as you can see, now the limit when x approach to positive infinity, the function is positive infinity. Okay, and the increasing part, as you can see from the function, it's increasing from 0 to positive infinity. Okay, let me remove this one so you can see the answer. Delete. Okay, now try to solve this question by yourself. Okay, and if you need help, please let me know. Okay, now let's go here to the transformation. The transformation part, it has contained 2 things. The first thing is the translation. The second thing is stretching or a compression. Okay, so first we are going to talk about the translation, which is moving up, down, or right and left. And you know that the moving or translating on x and y axis, okay, is h and k. And h always related to the x axis, k always is related to the y axis. And h is the translation on left or right, and up and down. Okay, so this is the translation. And to differentiate between x and y, or k and h, always h will be like an opposite side. Means if h given in the question negative, so you think we are going to the left 2 step. No, but if it's negative, take it always the opposite thing. So we are going to the right 2 step. If h is given as, let's say, 3, which is positive means we have to go to the right, but no, always take it to the opposite side, which is 3. So h always as opposite. But k, when k is written as 2, so that's mean 2 is up, same thing, don't change anything for k. And k when it's a 3 or negative 3, so we go down 3 step. Okay, so this is how we can, or the difference between h and k when you start to translate between them. Okay, now how you can know this letter or this number from the inside the equation is h or k. First, always, as you can see, h always is combined with the x. K, it's a sad letter, means it's all, as you saw in any function, always y in one side alone, same as k. Okay, example, if I have this one, okay, always k will stay alone. So both of them, okay, are happy because they are alone. I'm just joking. Okay, so both of them, they are feel sad because they are, okay, alone. They are not happy. So that's how you can differentiate between h and k. H always is with the friend, always x and h always as a friend. Okay, both of them are happy because now both h and x can translate on the x-axis. Now if you look to this graph, okay, f of x is adding with the k. Okay, so the function, it's moved up. Okay, and f of x is minusing k, so the graph is moving down. Here the same thing, x is minusing with h. Okay, so that means we're going to the right because it's always opposite side, and x is adding with the h, so we start translating to the left. Okay, so this is the means or the difference between translation h and k. Okay, look to this example here. Use the graph of f of x equal absolute value x to graph each function. So as you can see here, do you think this 4 is h or k? And as I told you, because this 4 is alone without, it's not with the x, so that's mean k is equal 4. h always should be next to the x, but I don't have anything next to the x here, so h is equal what? 0. So now the center will be 4, 0 and 4. Now before you start graphing this, okay, look to the parent function. Do you remember how we graph the parent function, the absolute value? Yes, it's always start from 0, 0, one step up, one step right, one step to the left, then we graph the function. But here, as you can see, the center, which is 0, h and k, it's start from 0 and 4, so you have to start from 0, 4, 0, 4. So this one will be the starting point. Then you have one step up, one step to the right, one step to the left, then you can graph the function. Okay, now how about this one? So 3 here, what do you think 3 it should be? This is 3 should be h, and always opposite sign. K, do I have k? No, I don't have k, so it will be -3 and 0. So now when you need to start to graph this one, you start graphing from -3 to 0. So -3, 1, 2, 3, 0 should be here. Okay, then one step up, one step to the right, one step up, one step to the left, then you can graph the function. Okay, then the last one here is -1 is k, -2 is h. So now what is h? H always opposite sign 2, k is the same sign -1, so 2, -1 is your h and k. So 2 to the right, -1 down, then one step up, one step to the right, one step to the left, then you graph the function. Okay, so this is how you can know the translation to the right or to the left. Okay, then the next part here is the reflection, or the, let's say, stretch or a compression. Now the reflection always related to the a. If a is negative, so we reflect it over the x-axis. Okay, so if the function up, it goes down. Okay, but if it's positive, okay, when a is positive, it's always should be above the x-axis because it's positive. When a is negative, so we reflect it to over or respect to the x-axis. And now when x is negative, okay, when x is negative, we're reflecting over the y-axis, means this side is x is positive and this side here is x is negative. So anything here will reflect it over the y-axis to become on the left side. Okay, so this is the reflection for a and for x. Okay, then we have the vertical stretch and the vertical compression, and horizontal stretch, horizontal compression. Now, how do you differentiate between the vertical or horizontal? Vertical always related to the letter A in the formula. So if you look to the letter A, any formula that we studied, A, when it's positive, okay, when it's positive and between, or let's say greater than 0, A is greater than 0, so means 1, 2, 3, which is a whole number. So that's mean it's a vertical, okay, vertical stretch. But when A is a fraction, which means A is between 0 and 1, like example 1/2, 1/4, 1/6, whatever, okay, so we call this one vertical, okay, compression. Okay, so as you can see here, the first graph, okay, the blue one was the original, okay, and A, if we multiply A with the whole number, so it becomes stretch. Then when as you can see, the A, when we multiply A with a fraction, 1/4, 1/2, or whatever, so the function goes compression. Okay, so this is how we can differentiate between vertical and the compression. Now the horizontal dilation, okay, it's related to the x, as I told you before. If x, okay, if the number next to the x is equal, let's say, or let's say, let me write it as inequality. Let's say if the number greater than 0, okay, let's say b, 1/b, so let's say 1/b, that's always next to the x, 1/b is greater than 0, so that means it's a horizontal stretch. Okay, and when 1/b is between 0 and 1, which is a fraction, okay, it should be horizontal compression. Okay, now maybe someone will ask me, what is 1 over b? Okay, let's summarize all the formula here. So we have the first formula is the linear formula, mx plus b. The second formula is y equal ax square. The second formula is the quadratic, 1 over b x minus h to the power of 2 plus k. Y is equal a 1 over b x minus h to the power of 3, so this is the cubic, and we have y is equal 1 over b, square root 1 over b x minus h plus k, and we have the absolute value a 1 over b x minus h plus k. Then we have the rational y equal a 1 over b x minus h plus k. So as you can see, all these functions, we just studied them in the first video, in the first part, but I didn't add 1 over b, okay, for all the function. Why I didn't add them? Because I just leave them to this step now to explain it now, because I need you to understand the function without it first. Now 1 over b is a part that make any let's say dilation on a horizontal thing. Means if the function make a compression or a stretch horizontally, so that's mean there is 1 over b in the function, there is a value for 1 over b, and always is different. Means if 1 over b is, because it's horizontal, right? Horizontal, okay, is a stretch and compression. Okay, so now when we consider this one is a horizontal stretch, and when we consider this one horizontal compression, a stretch, the 1 over b should be a whole number. Means, should be a whole number. Or the stretch should be a fraction, not whole number. 1 over b should be between means 1 over 2, 1 over 4, 1 over 6, or whatever, 2 over 3. And the compression should be greater than 1 over b, should be a whole number, means 1, 2, 3, 4, whatever. So it's opposite the a, but if you check a, in every a in the question, okay, a is the same thing. It's a vertical, okay, we have a stretch, we have a compression. So the stretch will be the whole number, and the compression will be, okay, the fraction, 1, 2, 3, or 4. Here it should be 0, less than a, less than 1, so it will be a fraction, 1 over 3. So now do you see the difference now between 1 over b and a? Okay, how, maybe someone will ask me, how do I know if it's 1 over b is given or not? Okay, I will give you just one example, but don't generalize that example for everything. But let me tell you, when you have any number next to the x, okay, and you have, let's say, something like this, okay, 2x minus 6, okay, as you can see, there is a common factor between this 2x minus 6, okay. So the common factor between 2x minus 6 is equal to, so 2x minus 3. So as you can see, we got the 1 over b, okay, even here or here or here, okay. Or sometimes you can just find it's already factored, which is 4, well, let's say 1 over 4 x minus or plus 2. So this one considered as 1 over b, okay. Now what's the difference between this and, let's say, this one here, x plus 6? So this one here will be a horizontal stretch because it's a fraction, that's what we did here, and this one here will be a horizontal compression. Why? Because we just mentioned this one here, okay. So I hope you understand now the difference between 1 over b and a. Okay, now let's check this graph. Write equations for transformation. Now, first thing, when you need to solve this equation, write the original function. So this is the original function given x squared. So x squared, graph it, so it should be like this, right? So it should be like this one. Now what's happened, okay, let me also draw it here for this function and this one here. Now next step, write the formula. What is the vertex form for the quadratic function? The vertex form is y equal a x minus h to the power of 2 plus k. Now as you can see, start with the center. Okay, start with h and k. Now the center, it's always start from 0 0, but what's the center for the new graph? The center is here. So now count the steps. It's from here 1, 2 and a half, 2 and a half to the right. Do I have any translation on y-axis? No. So only to the right 2 and a half, and so h should be negative 2.5. Why? Because h always should be opposite sign. So now the first part from the equation, y equal x plus 2.5 to the right. So this is the first step. Okay, sorry, not plus, minus, because it's opposite. Minus 2.5. Okay, then do I have any translation on k? No, I don't have any translation on k. So k is equal what? Is equal 0. So plus 0. But we don't have to add zeros inside the equation. Now look to the a. A here, is it positive or negative? Because it's reflected, so a is equal negative. Okay, it's equal negative a x minus 2.5 to the power of 2. Now we need to identify the point a. Is it 1 over 1, 1 over 2, 1 over 3, or 4, or 3? How do you know this one? Okay, you have two ways to know this one. You can just pick any random point in the graph x and y. Example, if I need to pick this point here. Okay, what is this point on the graph? 1, 2, 3, 4, 4, 1, 2, 3, 4, negative 4. So here is 4 and here is negative 4. So as you can see here, you can replace them to find a, then you can find a. But if you replace them, because 4 minus 4, so of course it will be 1 over 1. So because 1 over 1, so negative 1, so this one will be the answer. Look to this one here. First write the formula, a x minus h squared plus k. So now the first thing that you have to do is to identify h and k. And as you can see, the function is 2 step up, but no any step to the right or left. So k, it's plus 2, h is 0. So now so it will be x squared plus k, but what happened with the a? Same thing, it's reflected down, so it will be negative x squared plus 2. So this one is the function. Okay, now another type. Okay, describe and the graph transformation. Let's describe identity with the parent function of f of x and g of x, and describe how the graph of g of x and f of x are related. Then a graph of x and g of x on the same axis. Now the graph of g of x is a graph of this one here. So the first thing, look to the graph. The graph here is cubic, and as you know that the cubic function, it starts from 0 and goes up on the right and goes down on the left. Okay, and because it's 1 over 4, so that's mean a 1 over 4. So is vertical stretch or a vertical compression, this one? Okay, is it stretch or a compression? Okay, and because a here is a fraction, so of course it will be what? Vertical compression. Okay, so vertical compression 1 over 4, which is between 0 and 1. So vertical compression. Okay, and you can just make a small taper x and y to graph the cubic function. Okay, you can just pick 0, put 0 and 0 in the middle, pick 2 points less than, negative 1, negative 2, pick 2 points greater than 1 and 2. The second function, let's graph it together. So the first thing, we know that this is let's say a parabola, which is quadratic, x to the power of 2. So it starts from 0, 0, goes up and goes up here. You should know how to graph the parent, guys. the parent, you have to memorize how to graph it. Now this one, first thing, a is negative, okay, negative 1. So as you can see, first you have to reflect it down, the first thing. Then it's mentioned 0.2. 0.2 is inside the x. 0.2 means 1 over b is equal what? 0.2. 0.2 as 1 over b is equal 1 over 5, right? 1 over 5 is a fraction. And I told you, when 1 over b is a fraction, is it a horizontal compression or is it a horizontal stretch? Okay, so as I told you, if it's a fraction, it will be horizontal stretch. Okay, and if it's 1 over b is a whole number, okay, so this one called compression, but because it's a fraction, so it should be stretch. So now as you can see, the function will be stretched down, okay, like this one here. Okay, now try now to solve this equation by yourself, okay, and if you finish this, try to solve this one here, okay, and if you need any help, please ask me. Then the last one here is the graphing the piecewise function. Now the piecewise function is easy to graph, okay, but you need just to follow some steps, which means step 1, okay, draw guideline. Draw the guideline is the first thing. Then make table, okay. Number 3, graph, and make sure from the inequality if it's closed or open, okay. If it's closed, we use this type of inequality. If it's open, we use this type of inequality. Okay, now let's graph the piecewise function. So the first thing, what is the piecewise function? The piecewise function, it's just like one big function that has 3 smaller function inside, okay. Sometimes could be 4, sometimes could be 5, sometimes maybe 2. So the idea is the parent or the piecewise function is just you have more than semi-function, let's call it semi-functions. You have more than one, okay. Maybe you can have a constant, maybe you can have a linear function, quadratic, cubic, it depends, okay. So now the first thing, as I told you, the first step is to draw a guideline. How do you get the guideline? The guideline, you can get it from the interval. Interval always given in the question for every function. So as you can see here, the first function, okay, is x on the interval x minus x less than -1. So now the first guideline is x less than -1. So what is -1 here? So this one should be the first guideline at -1. Now the second let me draw it in the blue color so you can recognize them, okay. So the blue one is the first one. Now the green one is between -1 and 4. So the -1 here is we already did it, and now we need to put the guideline on number 4. Guideline on number 4, okay. Then the third one here is the function is x greater than 4, okay. Now we just did the last function will be in this area, the green function will be in this area, and the blue function will be in this area here. Now after we identify the guideline and the area that we need to graph for each function, now I have to make the step 2 is to make table. So make table for everyone. So the first function is 3x squared, make table for it, xy. Then the second function is -1, make table for it. Then the third, so let me do it in the green color, okay. So the second function, x and y. Then the third function in the yellow one here, make table for it. Now what's the value that you have to put in the table? You don't have to pick more than 2 value. 2 value is given, and always start with the value that's given in the interval. So the interval here, let's give you what? -1, right? So write -1. Now you need another value. How you can pick another value? Look to the x. X here is less than -1 or greater than -1. It's less than -1. So because it's less than -1, so you have to pick any value less than -1. Let's say -2. So now replace these two value in the first equation. So -1 square is equal 1. 1 times 3 is 3. Then -2 square is equal 4. 4 times 3, 12. Now plot this 2 point, -1 and 3, and it should be open circle or a closed one. Okay, as you can see, it should be an open circle because we have this inequality. So I have to put open circle at 3. Then the second point is -2 and 12. -2 and 12. 12 should be somewhere up, so it should be here. So now the graph will be like this. Okay, so this one is the first graph in the blue wall. Now look to the green one. The green one is -1. -1 is a constant, so you don't have to make table for the green one. So y is equal what? -1. So the constant is always a straight line. So straight line from where to where? From -1 to 4. So from -1, is it open or closed? Look to the inequality. It's closed one. So -1, we have to put closed circle. And on 4, look to the inequality. It's this one. So I have to put open circle here. And connect on the -1. Okay. Now the last function is this one here. We pick the point that's given 4, and it's mentioning x greater than 4. So pick any point greater than 4. Now replace these 2 points in the function. 4, let's put 4 here. 4 minus 5 is equal what? -1. -1 cube, -1. -1 plus 2 is equal 1. Now put 5, 0. So plus 2. So the answer is equal 2. So now the first point is 4 and 1. Okay. And what type of inequality is with equal? So this one. So I'm going to use the closed one. So 4 and 1, it should be here. And should be closed circle. Then the second point, it's 5 and 2. 5 and 2, it should be here. Okay. So now because this one, it's a quadratic, so you are not going to draw a straight line. It should be a curve because it's quadratic. If it's a linear, it should be straight line. Okay. I hope you understand this. So just to summarize it, first draw the guideline. Okay, then after that you can just erase the guideline. You don't need it. Okay, just erase the guideline. Then the second step, make table for each function. After you make table, pick the same point given in the interval. Then pick any other point, then you graph your function. This one will be your piecewise function. Okay, I hope you understand this. Now the last thing here is when you have the absolute value on x or absolute value on the y. So as you look, this is the original graph. Now if I put an absolute value for the whole function, okay, anything under the x-axis will go up. So the graph will be in the red one here, as you can see. Now if I put absolute value only for x, like as you can see here, okay, so the graph will be like anything on the negative side, okay, will be like the reflected like this one here. Okay, so this one, as you can see, when you have the absolute value. Okay, look to this question. So as you can see here, the absolute value is for all the functions, so that's why the function it's become like this. Now because this one it's here, so anything here will be changed different. Okay, sorry, this is not the function. The original function is this one here. Okay, if I graph it, so the function will be like this. Okay, 0, 2, -2. Okay, so the function will be like this one. Okay, like this one here. Okay, so now anything on the right side, okay, will go up. Okay, that's it. Now try to solve this guide their practice. Okay, and if you need anything, please ask me. This is the end of the lessons. Have a good day. See you. Bye bye.